All right, new chapter 1, part B, statistics. So we're talking about the normal curves, normal distributions, and 68, 95, 99.7 rule. This should be all very familiar from Algebra 2. There's going to be a little bit new vocabulary. We're not doing Algebra 2, but otherwise, this is Algebra 2 material. So, normal distributions. All distributions have the same overall shape. It's symmetric, single peak and bell-shaped. It's also known as a bell-shaped curve. The mean is located at the midpoint of the symmetric density curve and is the same as the median. If it's perfectly symmetrical, the median and the midpoint are the same, along the mean. Standard deviation, here's the symbol for it, measures the variability width of a normal distribution. You won't be tested on the name, but this symbol is sigma. Okay? So standard deviation, sigma, it measures the variability or the width of a normal distribution. Whoops. So the standard deviation, I mean, the mean here is, this symbol is mu, not mu, mu. So you can see the width is different. It's the second one is a flatter normal distribution. The peak isn't as high, okay? So the standard deviation is wider, bigger on the second one. The mean is at the center, right? Mu is at the center. Now, the standard deviation is at the inflection points on either side of the center. It's the point where the direction of the curvature changes. Now, the normal distribution, the bell curve. The variable x is the normal distribution. Then the distribution has a mean of mu and a standard deviation of sigma. It's represented by this formula in our layout. Okay, this means approximately. Okay, this means a normal distribution. That's the word normal. Okay, and then if I give it to you like this, like let's say approximately normal distribution 5, 2. That means the mean is at 5 and the standard deviation is at 2. That's all that means. It's just a layout for us to recognize what the information is given to us. All right, so example. In baseball, a player's batting average is the proportion of times the player gets a hit out of his total numbers at bat. Suppose we select a Major League Baseball player at random and let X be the player's batting average. The probability distribution of X is approximately normal. So first off, you're going to have to practice this. Wow, dead space. And you're just going to kind of get in the habit of being able to draw a pretty decent sized bell curve. That's not perfect, but it's pretty darn good. Okay? Now, what you're going to do is you're going to put the mean dead center. Okay? And we're going to put 0.261 here. Now, we're going to mark off the standard deviation evenly. And this doesn't have to be perfect. That's -1, +1. And we're going to put one like here and here. -2, +2. And then one down here, -3, +3. That's how we label it. Now, what we're going to do is we're going to do a standard deviation of 0.034. Now, all that means is we're going to add 0.034 and get 0.295. And we're going to repeat that and get 0.329. And we're going to repeat that again, and we're going to get 0.363. And then we're going to go this direction, and we're going to subtract 0.034. And that's going to give us 0.261. No, that's not going to give us 261. That's the mean. It's going to give us 0.227. We're going to do it again and get 0.193. And we're going to subtract again and get 0.159. And those are the different averages out so many standard deviations. Hopefully this is coming back to you. Now, estimate the mean standard deviation of the normal density curve in the figure. Well, we're going to come straight down here. So that tells me right there that the mean is 28. And then that's +1, -1, +2, -2, and so forth. So the standard deviation is 1. We could also write it this way. Approximate n 28, 1. All right. This should also be familiar. The 68, 95, 99.7 rule. It says if you have a symmetric or bell-shaped distribution, 68% of the population should be within 1 standard deviation, 95 within 2, and 99.7 within 3. So what that means is, I'm going to put my lines in here, attempted lines. Between these two numbers, 68% of the population lies. Between plus and minus 2, 95% of the population lies. And between 3 and -3, 99.7 of the population lies. Okay? Notice there's a little bit of space out here, a little bit of space out here for that other 0.3%. Now, this is also known as the empirical rule, and it only applies to normal distributions. Need to hit pause, go ahead, I'm going to move on. All right, the random variable x is ITBS vocabulary score of a randomly selected 7th grader in Gary, Indiana. And it's modeled by the distribution with standard deviation of mean of 6.84, standard deviation of 1.55. So again, we're going to get kind of good at this. Not so good. Should be touching the line. Pretty good. All right, so all we do is we put 6.84 here. Okay? And then we're going to draw in our plus and minus 1. And that's going to give us, we're going to subtract and add 1.55. So that is 5.29. And plus is going to be 8.39. Then we got our 2, 3.74, and 9.94. And then we're going to have our minus 3 and plus 3, which gives us 2.19. And 11.49. All right? Now, if you don't remember the percentages, it's really easy. You just have to remember 68, 95, 99.7. So, if from plus and minus 1 is 68%, if you divide that by 2, that's just 34%. Very simple. All right? Now, between plus and minus 2 is 95%. Okay? Well, we just take our calculator and we do 95 minus 68. That tells us there's 27 left over, divided left and right side. So that's 13.5% here and 13.5% here. Now, if 3 to -3 is 99.7, and we subtract the 95 from that, the previous number, that's 4.7. There's a left and right side, so that's 2.35. And then, think about it, 100 minus 99.7 is 0.3, left and right side, 0.15. So under here, there's 0.15 and 0.15. Tiny amount. Extreme, extreme. Now, it says, what is less than 3.74? Well, that's everything left of that way. So 2.35 plus 0.15 is 2.5%. So you only expect 2.5% of the students to be below 2 standard deviations. Find the probability a randomly selected 7th grader scores between 5.29 and 9.94. Well, you find 5.29, which is right here, and 9.94 right here, and all you do is add up what you see. So 34 plus 34 plus 13.5. Or if you already think about 68%, you can just do 68 plus 13.5, which is going to be 81.5%. We did this a lot on the test for this in Algebra 2. All right, draw a bell curve. A real small one because we don't have a lot of room here. So what's our mean? 64. What's our median? 2.71. So there's plus and minus 1. So 64 plus 2.71 is 66.71. That's a 6. And if we subtract, we get 61.29. 2 and negative 2. If we add 2.71, we get 69.92. And if we subtract, we get 58.58. And if we do it one more time, we get 72.13. Then we get 55.87. And again, we have 34, 34, 13.5, 13.5, 2.35, 2.35, 0.15, 0.15. All right. What heights correspond to 68% of women? Well, 68% is here to here. So that would be, 68% would be 61.29 up to 66.71. 95% is between -2 and +2. So basically, we're going to add all that. Say, well, we're not adding actually percentage, we're saying the number. So, sorry, that's 58.58. That's supposed to be a 5. Up to 69.42. Wherever you know, time to silly. Now, C is kind of redundant. What percent is between 58.58 and 69.42? We've already answered that. 95%. What percent are between 64 and 66.71? Well, 64 is here, 66.71 is here. That's 34%. And that is it.